Hello everyone, welcome back. Today let's solve the 27th top coding entry question from 48 top coding entry questions curated by Leetcode. We'll solve this problem using Python. This problem is to check whether a given a binary tree, root of a binary tree, what is binary tree? A tree which contains maximum two nodes. A tree which contains maximum child node, maximum two child node. It can be one, but not more than two. That's a binary tree. Now what we have to do is we have to check, given a root of a binary tree, we have to determine if it is a valid binary search tree. Then now what is binary search tree? Binary search tree is a binary tree where given a node, let's say given a node, all its left nodes or left child nodes, the values of left child node should be less than the root node. That is what it says. The left subtree of a node contains only nodes with the keys less than the node key. Imagine this is the root node key. All the values here, all the values, let's say if we have a tree here, binary a tree, all the values of those nodes should be less than the root node. This is the first condition. Second condition is right subtree, right side of the nodes should be greater than the root node. That is what it says. And the third condition is obviously the left tree, each node again should have a binary search tree. Basically it's the same thing what it's trying to say. This, if you have a node like this, so each node should be less than this left side of the subtree should be less than this node, and the right side of the node should be greater than this root node. That's what the valid binary search tree is all about. So now here, if you see here, if I start with this example one, the 1 is obviously smaller than 2, so and then 3 is greater than 2, so that's what it's a valid binary tree, because the left side is smaller than the root node and the right side is greater than the root node. This is the valid binary search tree. That is what it says, BST, valid binary search tree. Now in this example here, if you see, the root node is 5, left node is less than the root node, fair enough. Now when you go to the right side, if you see here, this is actually smaller than this, but actually in a valid binary search tree, it should be, this node should be greater than the root node. And of course, this, within this, it is, if you consider, I'm sorry, if you consider only this node, this tree, if you exclude this, if you disconnect this, this can be a valid binary search tree, because 4 3 is less than 4, which is the 4 is greater than the left node, and 4 is less than the right node. So this only, like, 3 nodes can be a valid binary search, but as a whole tree with 5 as a root node, this is not a valid binary tree. That is what it says, the root node's value is 5, but its right child value is 4, which is not a binary search tree. So what we have to do is basically, at each node, we have to basically check the binary left side of the binary tree and the right side of the tree, and then compare whether it's falling within the range or not. So I already have a code. I'll simply debug and then show you. First of all, what I'll do is, this is my VS Code. I'll simply put a breakpoint here. Simply put a breakpoint, and I'll quickly walk you through. First, what it is, I'll create a node. I've created a node, which basically I construct a tree here. I'll construct a tree where 4 is the root node, 2 and 5 are the left and right child of 4 node. Again, 2 root node 2 has 1 and 3, which like left side of a 2 is 1, and then right side of a 2 is 3. So this is of course a valid binary search tree. That's what I'm doing right now. If you see, I'll put a breakpoint and then run and debug. Alright, so now if you see here, the program starts from here. Alright, so it has created a root node with 4. If you see here, the value is 4, the left side is nothing, right side is nothing. So basically what happened is, the moment I executed, it went to this class, and then added that value, root node value. Now you see this, now I'm trying to add the left side. This is left side of the node. Alright, so the moment it finishes, you will see the root node is 4, which is this. The left node, which, if you see, the left node is 2. So if you see here, right node is still none because it has not executed. Left node, if you go inside this, it is 2. So left node, because it is already added. After executing this statement, you will see the right is still none, right? The right, it is still none. So if after executing this, you will see the right value also. You see here the root node, the left is, right node is 5. So the 4, left is 2, which is, which you see here 2, value here, right value is 5. 4 is the root node, left side is 2, and the right side is. Now again here, the, when I click on left and right, it has none values. When I go again at 2, there are no values. At 5, there are no values. At, again here it says left of left. So here a root node is 4, left is 2, again left of left node is 1. I'm trying to add that. All right, I'll keep adding. You see here, now you will see a binary tree with, now you will see the value root is 4, root value is 4, left side, when you go to the left side, 2, again 1. When you go to left side will have a left and right. Left is 1, 2, and then right is for 2, 3, right? So again, for when you at a higher level, 5 is the right node for 4, and there are no left and right node for that. This is the tree which I constructed. Now what I'll do is I'll call this function. This is the function which I need to execute. Is it binary search tree? I'll pass the root, which is 4, I'll pass it, and then I'll call it. Now basically, if it is a root is none, so if it is a empty tree, so obviously it is a valid binary search tree. If it is empty, then I'll return true. If not, what I'll do is, see, basically I'll start with 4. So for 4, because it is a major node, right? It is a 4 is a major node. So there is no left side, right? I'm starting with the, so to iterate through all the elements, I don't know how big is the tree. Right now I am at here. To start with, I'll start with 4 is the element. It should be left side. It should be middle. The condition is it should be middle. Left side, I don't know. It should be negative infinity. So I have negative infinity. It should be 4 should be, the middle element should be greater than these elements. So basically all these elements, but I don't know what is that element. To start with, I'm starting negative infinity, and it can go till, it can be maximum of positive infinity. So here, to start with, basically guys, this is the very important step here. To start with the first node, because it's a tree, unless I go check each and every element, which is what I'm doing right now recursively. To start with, what I'm doing is 4 is the root node which I'm passing here. If I'm passing here, 4th is a root node, which is what it says, but I need a starting point. What's the smallest element? What's the biggest element? The node should be less than the smallest element, and then the should be greater than the smallest element and less than the maximum element, the biggest element. So that's the reason I don't know what is the smallest element, I don't know what is the biggest element. So that's the reason I take a range from negative infinity to positive infinity. So there is no positive infinity, but it's infinity is nothing but positive infinity. The minimum value is this. Okay, maximum root value is 4. All right. So first element is 4. Is minimum value is less than the root value? Yes, it is negative infinity. This is what the main condition is. If this is not true, then it will return false. Basically, it's not a valid binary search tree. If not, if the conditions are met, so what is the condition of binary search tree? All the left side should be smaller than the root node, and the right side should be greater than the root node. That's what it says. If you see here, root value is this. It should be greater than the left side values are smaller, and the right values are greater. That's what this condition is all about. If you don't find anywhere this condition matching, then you return false. Else you keep continuing, right? So finally, so what is happening here? For the first time, I am iterating through the first element, because I don't know what all the left side what elements are there unless I go and visit, and right side I don't know what are the elements unless I go and visit. So I'll visit iteratively. For the first time, I'm here. I'm here. So I'll go through here. Now again I call this function bst, again same function recursively. This is the recursive function recursively. Now because I crossed the 4, I go to the left side of the node. When I go to the left side of the node, obviously I know, so when I go to the left side, right, left side in the tree, what happens when I go to the left side? I know the maximum element in a binary search tree. If you see in a binary search tree, all these elements, I don't know how small they can be. It can be negative infinity, but I know all these elements obviously should be less than these elements, right? So this is the maximum limit for this. So any numbers, so the condition is binary search tree, all these elements should be less than this element. What's the maximum element in this? The biggest element in this is this. So for the first time when I started, for the first time when I started, I don't know I don't know what is the right value. I don't know what is the right value for this. There can be many values, but when I go to the left side of the tree, the maximum element it could have is 4. So that's the reason left side I don't know. So that's the reason this is very important. Left side I don't know, but I know one any node of the left side, any node of the left side, which should be smaller than 4. 4 is the maximum node. So basically what I'm passing here is, this is what left side you pass, left root left, which is root left side, which is 2. You pass that element. Minimum value, we don't know what is the smallest element, because we don't know any of these values unless we visit. So we are going back, we are iteratively visiting the tree, we are traversing the tree basically, right? So we are here. So but we know what's the maximum value. It can't go beyond this. That's the reason we're putting this. This is a very important condition. I'll go on this recursively. All right, I'll check the condition. Minimum value is negative infinity, yeah. The root value is 2, maximum value is 4, obviously, right? Because it can't go any trees in the left side can't be more than 4. For the first time I took it positive infinity, because I don't know this side how many values are there. All right, because now I'm going to the left side of the tree. I know for the fact that these values are fair enough. Similarly, when I go to the right side, I know these right side will be greater than this element. So in that case, my when I'm at here, I don't know what is the positive values which are here. Or maybe when I'm at here, I don't know what is the positive value which are here, right? Sorry, when I'm at here, I know the positive value, this is 4. But when I'm at here, I don't know how maximum value I can have. So that's the reason I'll have the minimum, but I know this 5 can't be less than 4. So that's where the minimum value will be 4. And less than 5, and less than positive infinity, right? This will be case when I come to this node. Left side will be this. That is what these nodes are. And then node is when I'm traveling here. Right side I don't know, there can have, as of now in this node, this is not the case, because there are no nodes further. But when I'm passing this node, I'll not know whether, unless I visit that node, I'll not know whether that this is the last element or this is the last child. So that's the reason. So right now, if you go back and then understand this, so it will keep doing. Please debug this code, understand what each and every value is doing. Now if I am at this location, right, if I am at this location, I know for the fact I'm at 3 location. 3 should be less than this, because this is the root node, right? When you take only this subtree, this subtree, for the fact I know that this binary search tree, the left side should be less than this, which is this. Now when I'm traveling it here, the here it's a right side, right? So it should be, left side should be this node, and the right should be here. I know, because it's the entire left subtree, right? When it's entire left side, the maximum value is here. So when you debug, you will understand what I'm trying to say. uh, when you further debug, when you go further, there will be nodes where you process a node. Right now I'm at 3. Okay, the left's value will at 3. You debug this, understand, put a breakpoint and understand. At 3, the left side, the minimum value is this. It has changed here, right? It has changed. So that's what the condition is. This was the condition is, right? And the right side, when you go, this is the condition. The maximum value, when I'm at here, the maximum value is 4, because it can't go beyond this, and so on and so forth. For the first time, when you process a left tree left subtree, minimum value is the one which could be a negative as well. It could be based on the condition. This is what it is. When you process the right value, you don't know maximum value, process it, because the value should be the minimum value would be the the root node root value which you are trying to process. The in the right side value will be, when you basically when you are trying to process here, right, when you are trying to process, maximum value will be negative infinity. The minimum value will be this 4, which is the root value. When you are trying to process, this goes as this, and the root where right node is this. The maximum value for this 5 maximum values, when you keep executing, you will understand. uh, when you keep executing this, you will understand. Basically it goes to the root node and then come back. Minimum value is 4. Root node, what is the root node? Yeah, so if you see here, right now the iteration is happening right now for the 5. The minimum value for 5 is 4, right? And the maximum value, what is the maximum value? It's a infinity, right? It is a infinity. That's how you calculate, right? So that this is the node which went to that. So when you debug, you'll understand further. So finally, when you process, finally you will get an output as this is the valid binary search tree, right? You will get an output as is a valid binary search tree. So please put a breakpoint, create a node, and then iterate through this condition, and then understand how this working by exploring the tree, how it is generated. I have the solution here, similar solution. I'll just run it, and then it was already ran and finished, right? So I'll submit it. So it's the same condition. This condition is important, to check the root node is between the left side. The left nodes are less than the root node, and the right nodes are greater than the root node. That is what this condition is checking. And then left side, what values, how do you put, like you call the same function again and again by adjusting where you are. If you are in the left side, there are few conditions. The minimum value is, the minimum value is what you put. And if you're on the right side of the tree, the root will be the minimum value, and the maximum value will be the infinity, right? That is what you are trying to say here. That's all, guys. I hope you are able to debug and then understand the logic behind the valid binary search tree. That's all for this video. See you in the next video. Thank you for watching.